Hey, what's going on, guys? Hey, this is going to be 12.3 transforming functions, all right? Hey, we're looking at piecewise functions today, all right? Real quick, I just want you guys to have a look, make yourself familiar with these rules, all right? We got to know these rules, regardless of the function type, guys. They're the same rules, all right? So hopefully you had to look at those, man, and you paused it and looked at them, and you're ready to work, okay? So with that being said, let's go ahead and jump in on this video. Just smaller. All right, there we go. We got these piecewise functions right here. Here's the first one. All right, and we're going to go ahead and graph that first one now. And in the graphic, guys, look, all you got to do is pick values that fit the condition. All right, we just want to fit the condition. Like for example, this one right here, x plus 3, here's the function, here's the condition, all right, where x is greater than 0, x is larger than 0. So when we pick an x that's larger than n right here, all right, so if I take x is greater than 0, I take a number like, let's say 1. All right, if I plug in 1, all right, so I put 1 right here for x, I got 1 plus 3 is 4. All right, so there's 1. All right, let's pick another number, let's say 2. All right, if I pick 2, all right, because 2 is larger than 0, so if I go 2 plus 3, I get 5. All right, I can graph those points. Let me show you. 1, 4, all right, and 2, 5. All right, 2, 5. So I know that this first part does something like that. All right, now hold on. Let's do the next part. All right, now for this next part, I'm going to pick numbers. Yeah, this says x is less than 0. All right, x is less than or equal to 0. So I'm going to start right there. I'm going to start with 0. All right, because it's less than or equal to 0. So if I pick an x less than or equal to 0, say 0, and I plug it into this function, you can see this condition goes with this function. 2 times 0 is 0, right? And 0 plus 3 is 3. So there's 1.03, which is right there. And then we have, let's pick another x less than 0. All right, let's say -1. All right, -1 is less than 0. So if I go -1 right here, you get 2 times -1, which is -2. And -2, 3 is going to give us 1. All right, so there's a point, -1, 1. All right, and then for safe measure, I'm just going to do one more. All right, I'm going to say like -2. All right, so if I go -2, well, I get 2 times -2, that's -4. All right, and plus 3. Then that gives us, all right, and if I plug in -1 plus 3, -4 plus 3, excuse me, that's going to give me -1. So I plugged in -2, and out came -1. All right, so -2, -1. So I know that this part is going down right here. All right, actually, you know what I can do? I can use, all right, that's cool. I'm going to rock with that for right now. Now, let me clear this out so I can read the rest of the problem. All right, now for the rest of the problem, guys, it says write a rule for g of x, which means we're going to make a new function or a new piecewise function. All right, a horizontal translation of f of x 4 units to the right. So this function right here in the red represents f of x. All right, this is f of x. All right, we're going to move it to the right 4 units, which means we're going to make g of x. All right, so look, in a nutshell, guys, all these points right here, you can move them, right? 1, 2, 3, 1, 2, 3, 4. Right, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, you can move these, all right? And when you do that, Hold on one second. All right, let me try this one more time. Program is on the fritz today for some reason. So you have this right here. All right, there's the new move it to the right 4. All right, now this is the visual part of it. All right, this is the graph you moved it right 4. All right, now we need to talk about the math portion. All right, what actually went on with the function. All right, as we transformed it from f of x to g of x. And remember, g of x, all we did was move it to the right 4. See, values just moved to the right 4. Notice that nothing went up or down. All right. Now, if we look at our table, remember, if you want to have a function that goes to the right 4, you will write it as x minus 4. X minus 4. All right, so that means to the right 4. So we took that x minus 4, and since the x is the 4 is directly subtracted from the x in this first piece of this piecewise function. So I took it, here's how we got this. I took the x and made it x minus 4 because I need to move to the right 4. Right? And then you don't forget you still have the 3 here, so plus 3. All right? But not only do you have to do it to the function itself, that x has to be minus 4. All right, plus 3, because some of you are like, where'd the 3 come from? And where'd the 4 come from? Again, we moved to the right 4. So x minus 4 means to the right 4. And then plus 3. All right? Not only do you do it to that, you also have to do it to its condition. Here's the x condition. And the reason we do it to the condition is because, look, the x moved right. See this x right here? Now it's right here. I moved it to the right 4. So that x also has to be affected by moving to the right 4. All right, now why minus 4? Because remember the rule, guys, for horizontal translation. You use the opposite sign. So we're going to go right 4. All right, if I go right, it's minus. If I go left, it's plus. All right. So now, when we do this, so first I'm going to simplify the equation. All right, I have x minus 4 plus 3. Well, negative 4 plus 3, we can solve that to get x minus 1. Negative 4 plus 3 is negative 1, which gives us our new equation right here. Right here, I'm going to add 4 on both sides. All right, and we get x is greater than 0 plus 4 is 4. All right, that's our new condition, which is right here. All right. Now, again, the reason I'm doing this is to see how this is x minus 4. All right, all the x's have to be minus 4. Okay, so this is the new piece. This is the part of the new piecewise function. This is the new condition for that piece of the piecewise function. Okay. Now, I'm going to do this other part in blue so y'all can see it. See this portion of the function, 2x plus 3? Well, we move that portion, which is this bottom part, right 4 as well. All right, 1, 2, 3, 4, move right 4. So that x also must have the x minus 4 attached to it as well. Oh man, hold on, the computer's on the fritz. 2x minus 4. And the condition as well must get the same thing. X less than or equal to, x minus 4. All right, now distribute the 2 first to the parentheses. The reason this one doesn't have parentheses is notice that there's nothing in front of the 2. I mean, there's nothing in front of the x like this 2 right here. All right, so this one has the parentheses. Distribute the 2. You get 2x minus 4 plus 3. And plus 3 at 2x. You got negative 3. I'm sorry. Oh, that's not right at all. Let me backtrack. Computer messing with me. So you get 2x plus 3. There we go. 2x minus 8 plus 3 because 2 times negative 4 is negative 8. And then simplify that. You get 2x. You get 2x minus 5 for our new equation. All right, and then for our new condition, just add 4 over. Alright, and you get x, and 0 plus 4 is 4, which is our new condition. Alright, so when we do the U try, down here, we're gonna do this. Alright, first let's graph it. When you graph it, here's the function. Here's the first piecewise function. So we're gonna go, we need an x that's less than 0. Alright, x. So when we do that, let's pick an x less than 0. Let's say -1. So we have the -1. If we plug that in, -1 squared. Alright, -1 times -1 is +1, guys. So -1 squared is +1. So that's my first one, -1, 1. Alright, if I want to go with another one, let's say -2, because that's less than 0. -2 squared is -2 times -2, which is +4. So -2 squared is 4. Alright, so I know that this graph is going this way. Alright, now, for this next part, here's the function. This part's a little different. There's the function, -3. But you want x greater than 0, greater than or equal to 0. So I pick 0. What's the function? -3. There's nothing to plug in right here, guys. So it's going to be -3. Alright, even if I plug it in another value greater than like 1, it's still going to be -3. Alright, so we have this going on. So let me fix this one side, because they got to connect this piecewise function. So let's fix that. Boom, there we go. Oh. Alright, that'll work, man. We'll go with that. Okay. So there's the first function. Now, what this tells us, see how this is f of x plus 3? Well, the function plus 3 means move up 3. So all these points, 1, 2, 3, moves up 3. This moves up 3. Alright, so on and so forth. So what we end up with is this. Alright. Everything moved up 3. That's the visual part. Move up 3. Let me show you the math behind it. A little different thing happened though. I want to point out that you guys see how right here, this transformation will give us the -4 being subtracted from the x, all right, or the 4 being subtracted from the x. So that's why the x values change. I want to point out this. This is a y transformation. The y-axis, everything changed. X value is still -1. The y moved up. All right, this is still -2. The y moved up. This didn't change. Even right here, see how this is 0, but now it's 0, 0. You add 3 to it, it's 0, 0. You see what I'm saying? That x value didn't change, the y changed. So when you look at right here, all right, and we add 3 to the function for our new piecewise function, what happens is we're going to add 3 to everything, even the -3. If I take -3 and add 3, all right, I'm going to get 0. All right, so those are my two functions. And I want to show you that the piecewise function doesn't change. The condition doesn't change because, come on, finish. Right here to manipulate. There's only x's, so we don't change those. Oh man, this thing right here, I don't know what the video is going to turn out like because Fritz, man. I've got to get a new slate, I guess. So here's our new piecewise function. This is g of x. All right, this is g of x. All right, these don't change again, guys, because I moved the y value up 3. Even this one plus 3 is 0. All right, the conditions doesn't change because notice this thing didn't change horizontally. It just moved up and it moved up. So the y values changed. There's no y to manipulate right here, okay? Oh man, you know what I didn't do today? I didn't drop today's sponsor, man. Today we're sponsored by the Swedish Fish. All right, we're not actually sponsored by them. I'm just eating these, so what can I say? Shout out the Swedish Fish for being delicious. Also, the same people make Sour Patch. Delicious. I'm gonna eat some of these now, actually. So if I sound like I got food in my mouth, it's because I got a Sour Patch Kid in my mouth. All right. Now moving on. For this part right here, we're talking about the X and Y intercepts and how they may or may not change. All right. Now, they may change. Like, for example, X would change if it's a horizontal anything. Y would change if it was vertical, vertical shell, vertical compression, vertical stretch. The X intercept would change if something happened to the X value, like left or right, or a horizontal stretch or compression. All right. So let's look at this thing. The first thing I'm going to do is I want to talk about finding your X and Y intercepts. Finding your X and Y intercepts are pretty simple if you let it be, okay? So let me make this a little bigger so I can have more space to write. A couple things I want to point out to you is for your Y-intercept, if you got to find your Y-intercept, guys, make X 0 and then solve for Y. That can't get any more clear. To find your X-intercept, make Y 0, solve. So I want to start with the Y-intercept first, okay? X 0. So you have -2. Oh, I'm sorry. Hold on. Let me write it out. You guys know f of x and y are the same thing, right? Same thing. So I'm going to go y equals -2 times 0. And the reason I'm putting 0 here is because, again, to find the y-intercept, set x equal to 0. There's x. I'm going to make it 0. And then I solve it. Solve for y. -2 times 0 is 0. And then you have 0 minus 4. 0 minus 4 is -4. So y equals -4. That's my y-intercept of this, f of x. All right. Next, I'm going to find x-intercept for this same function. I'm not looking at g of x right now. Right now, g of x is not in our mind, so we're not going to look at it, okay? For the x-intercept, I make y 0. So I have 0 equals 2. Hold on, that didn't turn out right. -2x minus 4. All right. Now, what I'm going to do is I'm going to add 4 on both sides. So +4 plus 4. That gives me 4 equals -2x. And then this side right here, I'm going to divide by -2. Oh my gosh. Y'all pray for me, man. This thing here is not working out. All right, I had to clear it, try it again. Divide by -2. So we get x equals 4 divided by -2 is -2. All right. So what we got right here, here's the y-intercept for this one, f of x. Here's the x-intercept, f of x, okay? Those won't change. All right. Well, they'll change in a second. Again, these are the intercepts. These are where, right, this x-intercept will be whatever this function is, 2x minus 4. Here's where it intercepts the x-axis, and here's where it intercepts the y-axis. So it basically looks like that. All right, -4 and -2. All right. Now, what we're going to do is, let's reveal this g of x. We got to transform this thing by 1/2. All right. Now notice how this is multiplied directly to the x. All right. All right. It's multiplied directly to the x, 1/2 x. Well, what stretch? Because remember, it's the reciprocal. And I'm going to show you mathematically how it is a stretch. Notice that the x is affected. This is directly affected to the x. So this function and this function, they're going to have the same y-intercept. So I can tell you right now y equals -4. Because also, man, that's y equals y. This thing, man. Y equals -4. Okay. That's my y-intercept. They're the same because this only affects x. If you look at this, where is there an x? Where is there something to substitute 1/2 into? I can't make y 1/2. That says 1/2 x. So I can't do anything here. But if you look over here, 1/2 x, I could put 1/2 in front of this x because that's true. 1/2 x. Now I'm going to solve this for x. All right, this is going to give me my new x-intercept for g of x. How do you solve it? You multiply by 2 on both sides, right? Because that'll make that cancel. I'm also going to multiply by this side. Hold on, bear with me. So here it cancels, all right, and I have just x, and here I have -4, all right. So when you think about it, originally your x was right here. Now it's stretched, and it's right here. That's why this 1/2 is a stretch. It's stretched out, all right. It was like something like this, and now it's stretched to this. You see what I'm saying? It's stretched out here. So this is our g of x x-intercept. This is our g of x y-intercept. This is f of x y-intercept. This is f of x x-intercept. All right. When you apply the 1/2 x, here's what you get for the intercepts. That's all we're doing, guys, is looking at the intercepts right here. We're not looking at anything else. We're looking at just the intercepts and showing how the intercepts change, all right, according to the change in the rule, all right, or the transformation that's applied, okay? So let's look at this next one over here. Let me clear this out for some space. And again, I'm sorry, guys, about this thing. All right, for the y-intercept, find the y-intercept first, or the x-intercept, it doesn't matter. But find your intercepts for f of x. We're doing just f of x in purple. So to find the x-intercept or the y-intercept, you make x 0. So 0 squared minus 1. All right, 0 squared is 0, and 0 minus 1 is -1. So y equals -1. There is your y-intercept. X-intercept, you would do make y 0. So 0 equals x squared minus 1. We're going to add 1 on both sides. So 1 equals x squared. Now, I'm about to take you backwards a little bit. Remember when you solve with this x squared, it gives you plus or minus 1. Because the square root of 1 is positive 1. The square root of 1 is also -1. Square root of 1 times -1 is 1. Okay. So the x-intercept is plus or minus 1. All right. Plus or minus 1. Now, let's look at the transformation. For the transformation here, we're applying a negative out front. Now, if you look back at your rule, the negative out front tells us that we reflect the graph across the x-axis. All right, so if you got a graph and you had, let's say you had 2 right here. This is 2, y equals 2. All right, this is 2, 2. Well, let's say 1, 2. All right, up 2. Well, when I reflect it, I put the negative, it now becomes 1, -2. This will be your new y value, -2. All right, so now it's down. It went from up here to now down here. All right. So it reflected across the x-axis. So the y is affected. That's a y transformation. Notice the x's didn't change. The y's changed. All right. So when we go back to our and manipulate this thing, again, the x's didn't change. So the x-intercepts over here is still x equals plus or minus 1. But the y-intercept has to change. Now you also know that, see how that's a negative out front? That means that's a negative y. So I put the negative right here, right? And if I solve that, I'm going to the 1, and that becomes positive 1. All right, so this is your x and y intercept for g of x, okay? That's basically what we're looking for here. What is the x and y intercept of g of x, okay? All right. Let's do a couple more, and that will conclude the video. Actually, you know what? Yeah, let's work through them. All right, this one. Let's do it in red for f of x. Oops, I don't know how to click on yellow. Let's do it in red. All right. So for the x-intercept, remember you make y 0. And when you solve that, you go plus 1. And then take the square root. So x equals plus or minus 1. X equals plus or minus 1. All right. And then that's the x-intercept. Y-intercept, remember you make x 0. So y equals 0 squared minus 1. All right. You add 1 over. So 1 equals, actually, no, you don't even need to add 1 over. I'm tripping. That's just y. 0 squared is 0. 0 minus 1 is negative 1. There's our y-intercept. So x-intercept for f of x, y-intercept for f of x, okay? Now, we need to find the x and y-intercept for g of x. Well, again, see how this affects the x directly, negative x? All right, that changes the x values, not the y values. So the y-intercept is going to be the same. That didn't change because, again, that goes directly to the x. So I'm going to change this. All right, if I put a negative right here, right, that changes the signs. And ironically, see how this is the same thing? If I put the negative out front and then move the negative over this side, it's x equals negative 1. And if I move the negative over here, I get x equals positive 1. Well, I still end up with plus or minus 1. So x equals plus or minus 1. These happen to have the same exact deal, but same exact intercepts, x and y intercepts, okay? All right, let's look at the last one, man. Let's use another color, green. Here we go. I'm going to do the x and y intercept for, so again, y intercept or x intercept, or y intercept, you make 0. You make x 0, excuse me. You make x 0 for the y intercept. So 0 squared is 0, and 0 minus 4 is negative 4, so y equals negative 4. For the x intercept, you make y 0. All right, you're going to add 4 over. And then square root both sides, you get plus or minus 2. All right. Plus or minus 2 is x. All right. Now, for the g of x intercepts, what changes right here? This is 2 times x. So that means the y doesn't change. All right, y equals negative. All right, but now the x, you got to multiply by 2. So if I put a 2 right here, I just rewrote it, guys. Instead of x on this side, I moved it on that side. So 2x plus or minus, man, sorry about that. 2x Just like that. 2 right there, 2x. So 2x equals plus or minus 2, right? Oh, this last part, man, just don't want to take. All right, here we go. Plus or minus 2, right? And then I'm going to do these two separately so you can see. But what you have is, well, no, I can do it the same because I'm not adding or subtracting. See right here, I would divide by 2 on both sides. So what's 2 divided by 2? 1. All right, plus or minus 1. This is our new X and Y intercept for g of x. This was f of x, these two. This is the Y-intercept. All right, for g of x, this is your Y-intercept and your X-intercept. That's pretty much it, guys. I hope this is clear, and I hope this helps you, all right? Give me a thumbs up if you liked it. All right, and make sure y'all subscribe so y'all can keep getting the notifications, all right? I'll holler at y'all later, man. Peace.